So today we will look at salt hydrolysis. So basically what does the word hydrolysis mean? Basically this word hydro means water, right? This word hydro means water. Now what is the meaning of the word salt hydrolysis? Basically the combination of, or you can say the ions of salt when ions of ions of salt combine with OH negative and H positive of water, that is known as hydrolysis. Now what is hydrolysis? Basically the combination of ions of salt with OH and H of water, that is basically known as salt hydrolysis, right? So basically we have four types of salt, right? We have four types of salts. Number one we have, which is basically like, let me change the font size so you can see. Okay. Number one, which we have when there is a combination of uh, strong acid plus strong base, right? We have strong base. Second kind of salt we have when it is a strong acid plus weak base, right? Third we have when there is basically weak acid but strong base. And fourth we have when we have weak base plus weak acid, right? So we have these four types of salt: strong acid plus strong base, strong acid plus weak base, weak acid and strong base salt, and weak base and weak acid salt. So in these four salt, basically only three salts show hydrolysis. Only like these three show hydrolysis. Oops, let me write this. Only these show hydrolysis, and basically this salt show no hydrolysis. No hydro. This strong acid and strong base salt show no hydrolysis. No hydrolysis. And here we have hydrolysis of these three salts, right? So now let's look into why the strong acid and base don't show hydrolysis, right? So basically, remember one thing, that the hydrolysis increase when there is more weak component. It means if it's like right over here, like if the weak component increases, the hydrolysis hydrolysis also increases, right? So when the weak component increases, the hydrolysis also increases. So let's look in that why the strong acid and strong base they show no hydrolysis. That's what's the reason behind it, why they are not showing the hydrolysis, right? Let's dig into this. um, okay, we have number one salt, number one type of salt. Let me um, okay, number one which we have. Okay, okay, number one which we have strong acid plus strong base, right? When these both combine. So now let's take strong acids. Let's take HCl, right? Let's take HCl plus let's take strong base, which is NaOH. Okay. Okay. When this HCl and NaOH will combine, okay, when this is HCl and NaOH combine, they will form NaCl, right? So this NaCl is basically a strong salt, basically a neutral salt. Okay. Now, when like what was the definition of hydrolysis? That when the ions of salt combine with H positive or OH negative of water. So let's combine this let's combine this NaCl with water, right? With water. So after combining, let's look at how many ions will be formed. So here we will get this sodium positive ion. We get chlorine negative, and plus we get OH negative, OH negative, plus we'll get hydrogen positive, right? These are the ions that we get after when NaCl will dissolve in water, right? These are the ions, right? So now it's the like when this NaCl basically Na have a tendency to react with OH like positive and cation and anion, right? So when this Na will combine with OH, it will form NaOH, right? But one thing to remember that this NaOH is basically a strong base, right? And what is the basically tendency of a strong base to dissociate? As you know that we can't find equilibrium or we can't find Kc in strong things like in strong acid, in strong base. Their Kb is very much high. So we'll talk about this Kb and Ka too. But look at over here, this NaOH is a very strong base. It will not remain as it is an aqueous solution. It will not remain in in the state of NaOH. It will try to dissociate into ions into Na positive and OH negative. So it means the reaction will be something like this. There will be an equilibrium. It will be like this, in which the forward reaction will be only 5% and the backward reaction will be 95%. There will be 95% of backward reaction. It means in the solution, basically in solution, NaOH won't exist, but Na positive and OH negative will exist. Why? Because NaOH is very very strong base. It will try to dissociate, it will try to furnish OH ions. That's why it will not remain NaOH state. It will furnish its ions, it will dissociate into Na and OH negative, right? So that's why you can see that in the solution, if in the solution Na positive in solution Na positive ion is still there. So it means what was the definition of salt hydrolysis? That when the ions of salt will combine with OH and H, right? But they are not combining. In solution, Na positive is still there, which means there is no combination of Na and OH and Na or something like that, right? So it means there it shows no hydrolysis. Shows no hydrolysis, right? I hope this is clear to you that why the strong acid and strong base don't show hydrolysis, because they are very strong component. They don't need any kind of hydrolysis, because there it will be reversible reaction, because these strong components want to dissociate into ions, right? They want to dissociate into ions. They don't want to remain a stable, like we have HCl. HCl is a strong acid, right? It will try to dissociate into its ions, right? Because they are strong. Obviously, what's the tendency of a strong thing? That it will dissociate completely. That it will dissociate 100%. There will be 100% dissociation, right? There will be 100% of dissociation, right? So I hope this is strong acid and strong base is clear to you. Now let's dig into what if we have strong acid and a weak base, or we can say we have weak acid and strong. Let's take weak acid and strong base, right? As I said, as the weak component increases, the hydrolysis also increases. So over here you can see that there's one component which is strong, the base is strong, okay, but the acid is weak. The weak acidic component is weak, so it means it will show some kind of hydrolysis. Now let's dig into this. Now we have weak acids. Let's take any weak acid. Let's take formic acid, right? HCOOH is okay. I always do spelling mistakes. Sorry for that. Okay, this is formic acid, and if it will combine with, let's take a strong base. Let's take NaOH, caustic soda, okay, which is used in detergents and laundering and many things. Okay, let's take NaOH. Right, it will combine, and what do you think? What will form? Okay, this is NaOH. Now I guess it will form sodium formate and water will be formed. So there will be a salt known as sodium formate. It will be something like Na, right? This is known as sodium formate, and basically this is a strong salt, okay, because it is derived from strong base. Okay, let's dig into this. We have weak acid, which is formic acid. We have strong base, which is NaOH, right? Okay. There will be a salt form, which is sodium formate. Okay, now let's dig into it. When this sodium formate will be dissolved in water, what type of ions we will be getting? Okay, we'll be getting first of all HCOO negative ion, right? Then we will be getting Na positive ion, then we will be getting H positive ion, then we will be getting uh, OH negative ion. So these are the ions we'll get when we will dissolve this sodium formate into water. So now this sodium formate will basically okay, now we have Na positive ions and HOH. Now let's like if we combine Na, if we combine this Na with OH, we'll get NaOH, right? But over here the same thing, there will be reversible reaction, right? There will be reversible reaction, and there will be equilibrium like this, and the backward reaction will be 95%, right? So we can't say that this fully will be formed, there will be only 5%. Where I have the percentage one, there is 5% formation only, right? So that now we have now we have another ions which are these formate ions, and we have this H positive ions. When these formate negative ions will combine with these H ions, they will form HCOOH. OH, right? Here these, actually let me write over here too. Right, this reaction will be something like this. These formic ions will combine with hydrogen positive and they will form formic acid. It will be a there will be a equilibrium state, obviously. But over here, as this is a weak acid, this formic acid is basically a weak acid, right? So it means it is a weak acid. Obviously, there will be equilibrium, but there is a weak acid. It means there will be 95% formation of this weak acid, and we know, okay, we know that then when there is a weak acid, okay, let me write this reaction something like this. It's H. If this equation is like this, HCOOH, when it will dissociate it is something like this, HCOO negative plus H ions. Okay, we know that this is a weak acid. If this reaction is something written like this, we know that this is a weak acid, so the ions will not form. There will be 95 percentage 95 percentage of forward reaction. There will be 95% forward reaction, which means that it will not dissociate into its ions, right? They don't have tendency to dissociate into ions. It means it will combine. So when we will do opposite of this reaction, just these both reaction are only basically opposite, nothing else, right? Just there is a difference between reactant side and the product side. Okay, over here if I write HCOO plus H, so when this will reaction will form, obviously there will be 95 percentage of forward reaction. This over here, this will be more formed because this is a weak acid and there will be low concentration of this ions. So that's why, like, the ions of water are combining with the ions of salt. So it means this is showing basically, this reaction is basically showing hydrolysis, right? So let's write the equation of hydrolysis. Let me move over this for you. Let's write equation of hydrolysis, right? Equation of hydrolysis, right? It will be HCO combined with water, and it formed COOH plus OH, right? So as you can see, this is the equation of hydrolysis. This is equation of hydrolysis. So from equation of hydrolysis, we can get the solution will be basically the solution will be alkaline, or you can say the solution will be basic as in the end we have OH ions. In the end we have OH ions, so that's why the solution will be basic. So the pH over here will be basically the pH will be greater than 7. Okay. Um, I want that inequality sign. I don't know where it is. Okay, it's over here. It will be like this. The pH will be greater than 7. So I hope this salt of strong acid, strong base is clear to you, and the salt hydrolysis of weak acid and strong base is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you. Bye.